Thank you everybody for coming. My name is Morris Matza from IBM, the API Gateway lead for IBM API Connecting Data Power Gateways. And today I would like to talk to you about the new GraphQL Cross Directive specification, which I'm very excited about. Going through this, I want to start with setting up what's the problem, why is it important, and also what specifically is the problem that exists today, and how have people already solved it today. Every major GraphQL public endpoint solved it in their own way. And then taking a look at the standardization, at the spec. What is it? Some details, how exactly does it work? Why is that a better situation? And what can you do? What can you do to help with your endpoint or your product? All right, I want to start in asking why this problem is important with this slide, which is from 1 year ago today. My colleague Jim Laredo, who's here today, 1 year ago today, July 1st, at the previous APIDays interface, spoke about this. He shared this slide, which has all of the companies that were advertising their GraphQL adoption with the GraphQL Foundation, and then he first showed everybody who's got a public GraphQL endpoint at the time, right? And then everybody who didn't have a public GraphQL endpoint but did have some RESTful public endpoint. And it's 20 of the first, 30 of the second, approximately. Kind of asking the question, why are there so many people who are even adopting GraphQL and publicly announcing it with the GraphQL Foundation, yet not yet supporting public GraphQL endpoints, even if they have other endpoints that are public? And since I didn't want to show just the same thing this year, I've got a slide here with the Fortune 100, lots of big companies, just a sampling of big companies, and asking how many of them, instead of saying public endpoints, let's say public GraphQL, whether it's like companies like Facebook that are very public about their GraphQL and give lots of presentations about it, or companies that have public GraphQL endpoints. How many of them do we have? So we think it's about 17. Jim and Alan helped me with this. I think it's about 17 of these top 100. So this is our big question here. Why are more big companies not supporting public GraphQL endpoints, right? Even when they're adopting GraphQL. And in fact, if you look at the 17 out of 100 that I showed you, many more, like many more than 17 who are not we're not listing as GraphQL public here. They do publicly announce GraphQL positions of their companies. Their employees of their companies do announce that they're working on GraphQL projects for their company on LinkedIn. So many more of these companies are using GraphQL today, and yet they're not publicly using GraphQL. It's not public endpoints. And the same from the graph at the left, the chart at the left, right? Where these companies are publicly announcing they're using GraphQL and adopting it, but they're not supporting public GraphQL endpoints, even when they do have public RESTful endpoints. All right, so why not? Let's take a quick step back. I know this conference, a lot of you are well aware of GraphQL, but some people not. So we'll take 2 slides really quickly to just talk about what GraphQL is. Here's an example of GraphQL, what the provider provides. The provider in this case is saying they support a query endpoint. The query, you can query for a me, which means who am I? I'm going to take my user based on probably an auth bearer token or something to authenticate me, and then get my record from the database. And then you can ask for my name or my age. That's a type user, right? So I've got types and fields. Every field corresponds to a resolver function that'll be run on the back end. So here I send an actual query. I ask for the me, and I don't have to ask for the age. I can just ask for the name. So in practice, I get back that my name is Alice and no age because I didn't ask for it. I can get a little more complicated, right? I can nest queries and get much more complicated. I can nest queries, which is a join on the back end. But in GraphQL, it's just this nested query, right? And we said that every field in a query corresponds to a function, a resolver function you're running on the server. So when I start up, I run the me function, which gets me back a me in the JSON record to respond, and meanwhile has fetched a database record. And with that database record, I've got the name. So when I run that function, it's just pulling out a record very quick. Pulling the age is very quick. I already had the record out of the database. The friends is probably going to pull a list of IDs of all my friends from the database, and then it has to do the join, what would be a join in a database, right? It's going to have to take each of those IDs, find the actual database record, and return it. And now that I have all 3 of those records in my context, each time I can run the name function on it and get back the names. Now notice that I did ask for Alice's age this time, but not for her friends' ages. So I'm really in complete control, and actually there's much more control in GraphQL. We'll get to that in a moment. I can change the order that I want to get things back. I can change what they're going to be called, how they're going to be named in the JSON that comes back. The client's really in control. All right, so that's the whole background to GraphQL. Now, looking at the GraphQL client, obviously sending 1 million transactions a day is not going to go through the client. That's just going to be sending the queries. But when I develop my query, I've got this nice client to help me. This is a generic client here, but it's showing me information to my specific backends. For the rest of this talk today, I'm going to take a fictional backend that I've constructed for it's a real backend, but for a fictional bank, right? And so you see, imagine a mobile banking account, mobile banking app, and so I want to ask for my account and the different transactions in my account, things like that, the last 10 transactions maybe. In the left-hand pane, I've got rich, deeply embedded knowledge of my particular backend that is up to date. It's not just what my bank served yesterday or a month ago. It's this minute. It's using GraphQL not only to query the actual data, but to query the metadata of what types and fields are available. And so this is completely up to date. That means it can give me syntactic font coloring in the, you see the different colors in the left-hand pane, all based on my particular bank GraphQL endpoint. It's giving me autocomplete based on where I am in the query and based on my particular up-to-date schema. It's context-aware help. You see the pop-up here. And then once I got the query, and at every point in between, it can do local validation to tell me whether it's valid. All right, so this is really great. It's part of the overall advantage of GraphQL. GraphQL's main principle is that the client is complete control. But as I want to get to the problem here, a key problem we're talking about, I want to talk about one high-level advantage within the client being in control. We already mentioned this, that the client is in control of the contract. So the client can say, I don't want to get back in 3 different round trips. I want it all back in 1 round trip. But I don't want everything from all those 3 parts of the schema. I want to get only parts of the graph. I don't want to overfetch. I want to get exactly the data I want. I want to get it in the order I want in my JSON object. I want to get it named the way I want in my JSON object. I'm completely controlling the request response contract from the client, which is really great for GraphQL. And we could talk about that more if it was just a general GraphQL Advantages talk. But I want to talk what problem? Letting the client be in complete control of the contract obviously leads to a bunch of problems. All right, let's take a hypothetical query here at the top left, where I say fetch all the data, but not really all the data, right? I want to get the users back from my database, but there might be tens of thousands, hundreds of thousands of users, so I'm going to limit it to only 1,000 users. The second line, I say for each user, give me all of his orders that he's got from my company. Maybe it's a retail company, but not all of them. Just give me 1,000 because I don't want to take necessarily all at once. Now, obviously, 1,000 users, 1,000 orders for each of 1,000 users. This could be up to 1 million orders coming back. And then for each one of those, I want the payment details. I want to know the current status of that payment. Has it been approved? Has it been paid? Is it paid in full? For that, I'm going to need to call out to a third party. So that's not my retail company that's answering the payment status, right? I'm going to have to call out to some credit card company or somebody like that. And I might have a situation with that third party where I'm even paying real money. Like maybe I've got some SLA that tells me that for a certain amount of traffic, I'm paying a certain amount of money, or maybe I'm paying some 1 penny per call or whatever it is, 1/10 of a penny per call. But I'm paying for that payment detail. And there might be 1 million of them in this 4-line query. That's obviously out of control, right? Whether it's malicious or not. What can I do about that? Many things for years. GraphQL's had a few solutions here. One is I could set a timeout and say if this query takes too long, then just abort it, right? Obviously, that's got some issues that I don't care about it taking a little more time to get lots of orders from my database, but I do care about it taking a lot of time to gather the payment details because that's going to somewhere that costs me money. So I could also dynamically sum up the cost. Like let's say every time I get to payment details, I increment a counter. If that gets to 500, then I abort. So I don't care if you're getting lots of local data, but when it gets to data I care about, if you ask for too much, then I abort. I could also do stuff before I even start the query. Like I can statically look at the depth of the query or the width of the query and say if it's too deep, that's probably getting dangerous. I don't want to do that and not even start to run the query in the first place. Or I can do more than looking at simple things like depth and width. I can really do full cost analysis, static analysis of the query to figure out how bad it's going to be, how expensive it's going to be on my backend. That could be CPU that I care about, or it could be about memory. It could be about money, how much money I'm spending on the third-party calls. That's obviously a lot of work, right? And all the top 3 are not. So we would tend to want to do something like the top 3, which I can do very easily. I can just put it in the resolver function the way I would do for REST. But the top 2 really are dangerous. right? I mean, there's a big risk that if I spend 100 milliseconds before I abort, or if I do 500 calls to payment detail before I abort, I'm doing the dangerous stuff, not as much, it's better, but I'm doing a bunch of it before realizing that was an attack. And so in a distributed denial service kind of attack, right, that can be very dangerous. And so therefore, our approach that we recommend is doing the static analysis here. And that's regardless, like the easy things like document depth and width. But in this case, you see it's a depth of 4, a width of 1 per each level, not much, and yet it's very expensive. So I really have to do the full static analysis. And just to point out, this is a real problem in the real world. It's not just theoretical. You can look at the big things like big open endpoints like GitHub and check for yourself. Here happens to be an IBM, one small corner of the IBM cloud as shown by GraphQL Voyager. Notice that, right, it's very common for single types, and many of our customers, we've seen this, single types to have dozens and dozens of fields that somebody could, in the worst case, query all those fields at the same nesting level, and many, many connections between objects where they could get lots of depth. So these are real problems. All right, how's this solved today? When you look at how big of a problem this is, it should be kind of clear that every major public GraphQL endpoint has dealt with this, right? It's a problem for everybody, and they had to solve it by now. They couldn't have been out there without solving it. What do you need to solve in particular? All right, number one, threat protection. You want to make sure that a single request cannot blow up and be a humongous amount of CPU or memory or monetary cost on the backend server. Excuse me. All right. Besides threat protection, how about rate limiting? You want to make sure that a single one of my clients can't use so much of my backend server resources that other clients don't get as good responsiveness on their requests. And number 3, monetization, right? Why are we in this business of APIs? For most people, if you're going to provide a whole lot, then you want to be charging more money, right? To your clients, to the API consumer. So I want to go through 3 examples of where big public endpoints have done this. These are not limitations. I'm just going to show a couple screenshots from each of what they document in their web pages, which you can go look at for yourselves and get the links. But GitHub does more than just threat protection. They all do more than what I'm listing here. But I just want to look at GitHub specifically for threat protection, Yelp specifically for rate limiting, and Shopify specifically for monetization. These are 3 of the most famous big public endpoints out there for GraphQL today. So for GitHub, here's a picture from their documentation. They say that you must use the connections pattern, the relay or GraphQL pagination pattern to specify first and last arguments, not leave lists unbounded, but say how much and most can come back from the server. And those limits must be 100 at most, no more than 100. And then they do a static analysis. They're very upfront about that. And if it comes back that if you had, if you ask for all the PRs on a repo or something, and there's only 3 PRs, you're only going to get 3 back. But if you, at most, if you got back as many as you asked, like if you say 100, if there really were 100, then at most you would get 500,000 nodes back in a single request. More than that, they will cut off with threat protection. All right. Yelp has this nice table in their documentation where they say the different parts of their graph have different number of points because they know that on their backend those resolver functions cost more, right? So they're going to pass that on to you, and then whatever you do, every individual client gets a limit of 250,000 points per day. It resets at midnight GMT, and if you exceed that in that 24-hour period starting from midnight GMT, they will cut you off as part of rate limiting. So that's rate limiting very clearly. They can't, for GraphQL, you cannot just say 100 per day or whatever, 1,000 per day, right? Because some requests might be really big, some small. You have to analyze the expense or the cost of that particular GraphQL query and use that, and that's what Yelp's doing for rate limiting. And Shopify, here I modified the screenshot. So we've got the screenshot, look at the bottom, they're telling us how they evaluate cost of a query, that mutations default to 10, connection fields to 2, plus the number of objects, and they're going to use first and last from the pagination, from GraphQL pagination to figure out what how many objects are coming back in the list. Eventually, they calculate your points, and they give you 50 points per second for the standard limit, or 100 for the Shopify Plus, right? And I put the thing I modified is putting the prices in here. It's up to Shopify how much money they charge. Don't trust my prices. That's what seems to be on their website right today. But the point is just that it is monetization, right? They charge more for the professional enterprise plan, and then the professional enterprise plan gets more points per second. But it would be meaningless to say that the enterprise plan gets more transactions per second when it comes to GraphQL, because a single transaction can be humongous or can be tiny. So they need to be adding up points. All right, so this is what these three do. We talked about them in depth in the last 3 slides, not that much depth. What do we notice in common? The common thread here is they've got custom code for enforcement, right? They all handle it. Everybody needs, if you're going to do GraphQL for a big public endpoint, you need to be putting in a lot of effort to make sure you calculate the cost or expense of every query when it comes in, because each one could be different. And each one of them then documents that for users on their web pages, right? And so if I look at these web pages, I see that what do I end up doing for any of them? I can have a graphical or GraphQL playground, whatever it is, kind of UI for the client that has richly embedded up-to-the-minute details on everything going on for fields and types. And then I have a separate web page that I consult, some static web page that tells me how to understand what's going on for threat protection, rate limiting, monetization. Right? That's clearly lacking. The left-hand picture is the one we want for the GraphQL promise, and the right-hand picture is not quite living up to it for these new features. Right? So that's why we have this new spec. Looking at this topology, the left, this is any typical GraphQL implementation. You've got the left is the client, the middle is 0 or more middleware proxies, the right-hand side is your server, which might include GraphQL middleware and definitely includes your GraphQL execution engine. So what are the goals of the spec? For the client, the goal is that he obviously is in control of the contract. That's the way GraphQL works. And he wants to know what's costly or expensive before he sends his requests so that he can form his requests appropriately. The proxies in the middle want to be able to enforce threat protection, rate limiting, and monetization based on what they know from the server, just like they can enforce other things today. I'll get to that in a moment. And the server needs to be able to express what the cost is of different parts of the graph, and then wants to be able to even enforce in the GraphQL middleware inside the server various limits. Right? So overall, what does this mean at a high level? There's 2 things. With the schema, I need to be able to specify more than just types and fields. I also have to be able to specify cost. And then at every level, wherever we do it, we need to be able to figure out the cost of a given query given that schema. Right? So that means that if I consider what I'm going to do, I'm going to take the previous state, just the real normal GraphQL spec, the base core GraphQL spec, says that a server provides the types and fields. The middleware enforces. So today, middleware already looks at the types and fields, and like if you try to use a field that doesn't exist on a type, it will validate that, decide it's invalid, and reject the query so that it never even gets to the backend server. Right? So enforcement's happening in middleware today based on the schema provided today by the server, and the client exposes all that information unless you use it when constructing your query in GraphQL or any other UI. And so what we're adding with this new spec is that the server can also, besides the types and fields, specify the cost and expense. The middleware can similarly enforce based on those items, and we'll get to that. And then the client can similarly use that for constructing queries. All right, so the first step, we said 2 parts: specifying the schema and then calculating the cost. So the first part is in the schema, right? I'm going to go through a few examples of things that the spec lets us add. One of them is this @cost directive. So it says you can add to the schema your cost directive. What problems is this solving? That some types are more, I'm talking about type cost in particular, you can add it to types here. Some types are more expensive than others. In general, when we're talking about type cost, we're talking about how much data is returned, right? A type corresponds to something that you're returning in your JSON data that's coming back from the query. And so if we evaluate those types, it corresponds to the data you're getting back, but maybe also to how expensive that type is for me to process. So here I've got part of my bank schema. We look at the first type that I'm showing 3 types. The first one's address. It's a moderate one, right? It's got a few scalar values. It does not really have a lot, but it's not that little. It's not just 1 or 2 fields. So I assess it's got a cost of 3, and you see in the schema itself, I added in cost weight 3, right? The second one is credit card. In this case, I'm going to assume that to get the credit card data, it's actually going off to third party. I'm calling to the credit card company's API, and it's not in my enterprise, but going to a separate enterprise. I have a limited SLA with them that doesn't let me do that so many times per hour. And so therefore, I want to make sure that I don't do it too many times. So I'm going to pass that cost on to my clients to say if they're querying for credit cards, it's got a higher cost. So I had a cost of 13 there, not just 3. And you see that's also annotated in the directive directly in the schema. And then the last one, account connection, this is just part of the connection pattern, right? So it's a real part. It does return real data going back to the client. I could give it a cost, but here I'm going to overwrite the default cost of 1 and say that it's got a weight of 0. To model as free because, instead I'll model the actual real data parts and not the connections pattern. All right, that's a choice. You can make any choices. The point is not the actual cost here, obviously, right? Obviously, the point here is that when you know your backend, you know your resolver functions, you know where you're getting your data from, then you can make an intelligent decision and advertise it in the schema. All right, so that's type cost. Next time I talk about field cost. When you run actual resolver functions to get the values of fields, that gives you a every resolver function is a cost, right? It takes CPU on your backend server, it takes memory on your backend server, it possibly gives you a real dollar cost, monetary cost, right? So let's take a schema, one of the types in this bank schema, and type for account. Let's look at 3 of the fields here. For joint owner, this is saying for a given account, I can not only get the owner, but also the joint owner. Let's suppose that the joint owner is stored in a different database that's in a different data center in a different geography. So if my main server, maybe my enterprise is in Asia, and the main server is in Asia, but I need to go to Europe or to the US to get this joint owner database is in a geo in the Americas, I'm going far, which means that it's going to take me longer. It also means that while I'm waiting, I'm going to keep a bunch of data in memory on my server in Asia, right? And so that is going to cost me more on my backend server in memory and CPU, whatever it is. So I give it a higher cost. So I give it a cost of 5. And notice in the schema, I've annotated it with a directive that's saying cost of 5. For transactions, this is the bread and butter, right? Imagine any mobile banking app you've ever used. The main thing you do is you say, I want to go into my account and see my last 5 transactions. I want to see whether that transaction showed up yet, see my current balance, right? So this has been optimized. The bank, this hypothetical fictional bank, already optimized it for decades, right? They optimized stored procedures in their database to make it faster. They optimized various caches for it. They optimized their database schema. They got all kinds of experts to do database optimization. It's very fast to get the transaction. So they give it a cost of 1 here because it's not going to cost them on the backend server. Family members, on the other hand, has a different issue. It's personal sensitive information. And so it might be relevant, maybe you limit who can get this from your graph, but the people who can get it, that's good, they should be able to get it, but it's still sensitive. We're gonna have extra encryption. The encryption costs CPU on my backend server. The encryption costs extra memory to do the encryption algorithm. And so that's gonna have a higher cost, let's say 7. Again, the costs are not important. The point is that knowing your backend will affect what cost you put in the schema. The middleware should not know, the client should not know, but you should know, and if you express the cost, they can calculate based on it. All right, besides type and field cost, what affects these a lot, as you saw, remember we saw that GitHub said that, and Yelp and Shopify were all talking about that you need to use the connections pattern, you need to give them first and last, right? I have to have some way of knowing how big lists are, right? So if I don't know how big a list is, then what's returned by that list, if it's many, many objects, will give me a big type cost, right? And if it's many, many objects with lots of fields queried in them, that means I'm calling lots of resolver functions. That's a high field cost. So I have no clue what the type cost and field cost are unless I can bound how big the lists are that are going to be coming back. So let's take the same account with the transactions field here that I did on the last slide. All right, and assume it's using the standard pattern. You can use whatever pattern you want. We don't limit to the relay pattern, but let's say you are doing that, GraphQL pagination. So you've got first and last. This is very typical. So then what I'm going to do is augment my schema with with this one new directive, list size, and 2 arguments. Slicing arguments is saying which of these arguments are slicing arguments. In this case, it's first and last, right, which is very typical. But we've got a whole bunch of customers. I've seen their schemas, and they don't just use first and last. They do something, they're passing in a GraphQL input type here, which itself has another type inside it, which inside it has arguments, which are actually the ones that have that control the list size, stuff like that. And so you need a way to be able to specify what actually is the slicing argument here. And then the other thing is, because it's the standard pattern, it's not returning a list directly, it's returning a transaction connection, which has a field called edges, which returns the list. So I have to tell it that the sized fields are edges. So first or last will size the field's edges. Okay? And that lets me know how big the list is going to be statically. I can also, what if I look at a case where I don't have the connection pattern, right? I don't have connection objects. So here you see transactions instead returns a list of transactions directly, right? But look at the documentation. The documentation says that it's returning the 5 transactions before or after the given transaction. I can't return all transactions, that'd be crazy. But I could return only 5, and 5 at a time. Maybe I don't let you be in control at the client. So if it's 5 at a time, then there's nothing coming in the input query to tell me that, but it is set by the schema. So I similarly need to set it in the schema for my annotation. And here you can see I add the assumed size argument to the list size directive, and I say assume size 5, which means that's an upper bound. You're never going to get more than 5 back. If there are only 2 transactions left after your after cursor, then you might only get 2 back, but you're never going to get more than 5. So again, I can calculate an upper bound. And of course, these can be combined. So here you see one that doesn't return an array. This is a case of transactions using the connections pattern. It's returning a transaction connection, but it's still documenting that it's going to return at most 5. So it uses the assumed size argument to say at most 5, but the sized fields to say that the thing being sized is the list returned by the edges, right? Okay, hopefully you're following all this. This is these are just a few examples. I think this covers all of the most common cases that are used. There is a lot more. You can check out the spec yourself and see the extra cases that are handled here. But I think these really are the main ones. And so if those are the main ones for what you specify in your schema, then the next question, remember we had 2 parts, specifying the schema and then calculating the cost. So I want to quickly go through one example of how you would calculate the cost. Here you see that we've got a query, very typical one for our mobile banking of the app, right? I'm going to ask for an account and his last 5 transactions and a couple pieces of information on the transaction. And I want to know whether there are more, and it has next page, so I know whether to have a button so that you can scroll to the next ones. All right. There are different kinds of analysis. Again, point you to the spec if you want to see more about dynamic cost analysis or the response query analysis. Here we're going to look at static query analysis, right? Which means that I've got the query, I'm not yet running it, and without running it at all, without the execution engine, I want to know how expensive might it be upper bound to run it, right? So I go through down the query from top to bottom, right? I get the beginning, I realize I'm going to have to be returning a query, right? The query type, the root type of the schema, and so I keep a track. That's one query type. I get down to the account field. That's going to run the query.account resolver function, so I count that up at the bottom right, and now that's going to return an account type, so I count that at the top right. The name field next, I'm going to skip because it returns a string, so I'm assuming by default that that's weight 0. The spec allows you to say, no, that is significant. I could have a weight and I would not ignore it, but by default, we're going to assume that anything that's a scalar type means probably it's just a bit of information that's on the JSON object you already fetched from your backend database in the parent type, and so it's probably pretty cheap to get that type out, that string out. We're not going to count it. All right, transactions is where it gets interesting. I only run this resolver function once, regardless. But remember, I added the cost directive. So I added a cost directive that says the slicing arguments is first and last, so including last, which is the relevant one here. So I can get out the 5 from that last argument and know that 5 is concretely how many list items we returned at most. And then the sized fields is edges, so I know that's where I'm going to hit the list. So I save that information. I realize that 5 is going to bound the edges list. I continue, and page info is again pretty standard, adding 1 and 1. When I get down into the edges, this is where I say last was 5, and therefore that bounds how many things edges returning. So if you look at the bottom right, field counts, I'm only running that resolver function once. The edges function is only run once, but it returns a list of 5 things. So at the top right, I've got 5 transaction edges returned, which means that when I go down into that, then I hit the node, the transaction edge.node resolver function. That one's going to be run 5 times, once for each transaction edge. And then each time it'll return a single transaction, but since it's being run 5 times, that's 5 counts. So that's the top right. Right? That finishes my traversal through the query. Now all that's left is to add up the costs. As you saw, we can have different costs for different counts, for different fields and different types. So it's really a weighted sum. But in this case, let's just assume that every weight is 1, so that a weighted sum is a simple sum, which will make it easier for you to do in your head. And if you see all the numbers at the top right, they add up to 14, and the bottom right, they add up to 9. So I'm adding up my type cost and my field cost. And that's basically all there is to it, right? I calculate, I augment the schema in enough ways that can be clear what the cost is, and then anybody at these various levels can be calculating the cost, right? What's the benefit of this, right? We saw that GitHub and everybody else with their public endpoints is already doing this, right? And at IBM, we have public endpoints at IBM. We're already doing this, but everybody's doing it separately. There hasn't been a standard way yet. And so this is giving a formal spec, which gives you interop. Interop means that you can have vendors to provide you parts of the solution, right? I don't have to solve it for every single server the way we've been doing. Instead, a server can use middleware or even middleware in the server, middleware in a separate proxy, or the client can be independent and independently figure out what the cost is. So we think this would be useful for standardization. It obviously means no vendor lock-in. You can work with anybody, and then thereby being enforcing threat protection, rate limiting, monetization. All right, so I want to show you a little more in a demo, but first just asking, what do you do from here? Right, we've got the spec out now, cost directive specification. There are more videos and intro that is out on the web on this URL. You can, I'm sure you can get my slides here after the conference with the URLs. Then there's the formal spec itself, which is available at within that. There's a link to it there, but at this URL. And we'd like to work with people on it. So here is the URL to within the GraphQL Slack workspace. We've got a channel in there that we just set up. We just released the spec about a week ago, brand new. And so this we just started this Slack channel to discuss it, and you can come discuss it with it there. And if anybody if you have your own GraphQL endpoint and you want to protect it, happy to work with you on that and tell us what more you need or how to evolve the spec. Please join us. And if you are a vendor, right, and you provide some GraphQL functionality, and you can also integrate this, please come talk. Right? A couple other companies have already contacted us personally to talk to us. You can either do it publicly in that Slack channel or personally contact me. Check with the conference; they can give you a way to contact me, or on the conference I've got my Twitter and LinkedIn up there. You can contact me, and I'd be happy to talk to you separate. So far, people have contacted me separate from the public one. All right, so now. With that, I think I'm going to show a couple things in the demo and then go to questions. So here I am in API Connect. This is one example of using the spec, right? We've got this is showing, again, the same bank schema, right? I want to first just look at these kind of things. Like we got these same fields I talked about before. Joint owner, we said that it's got more cost. If I look at the view source button, I can see the actual schema and see that here I've got all these fields: joint owner, transactions, family members with no directives, right? And so, I mean, this tool allows you to just import. So I can use the spec, modify my schema, and just import it. So I can use it as a spec, and I don't need to use this UI. But if you want to use this UI, it lets you modify costs here. So I can, just increase joint owner to 5. I think family member I said 7. I can type in whatever types I want. Values I want here, and then I can go and view the source again and see that it's updated. So the joint owner now has a cost directive in here, weight 5, and the family members a cost weight of 7. So right, so it knows the spec and it can just do these things for me with cost. Something else that is very important, as we talked about, without that list size directive, there's no way in the schema itself to know how big lists are going to be bounded to. But while I can't know, I can have guesses. The closer your schema corresponds to the relay pattern, the GraphQL pagination pattern, or something standard, then the easier it is for us to guess. So we built in some intelligence into the system here, right? Some limited level of artificial kind of intelligence there to figure out if you use similar patterns, the normal patterns, what it is. So you see here, transactions has a little warning label here telling me that there's no way to know, like, did this first and last really mean limits on the type? I don't know. I can click on that and it tells me what's the problem. The problem is the value of this field is a list of the composite type, which has neither an assumed size nor any slicing arguments, right? It's telling me exactly what the problem is. It says if it's encountered, the API gateway cannot set a limit on the number of objects returned from the list. And so there's no way to do anything, right? It's got a number of recommendations. They're ordered in the order of likelihood to be the correct answer, right? There are several, but the first one clearly is the best one, right? List size with slicing arguments of first and last, and the sized fields as edges. That matches the standard pattern out there for everybody, and it happens to be the right one here. So I click apply, and it automatically applies it for me. which you see now in this table. It's telling me slicing arguments are first and last, and size fields is edges. And if I look back in the source, I can see that here, transactions, it has the cost that I gave it. Oh, sorry, the other two have the cost that I gave them. I didn't give it a cost. And transactions has the here, first and last, and the size fields of edges, right? So it's all added spec compliant into the SDL, which you can then download the SDL that you've constructed and use it somewhere else, or you can check it into your source control, etc. All right. So not only that was not the only problem. I have a bunch of others. So if I say apply all, it's telling me all of the recommendations it has across the schema. They all actually look reasonable, right? It's important not to accept ones that are wrong, but these all look correct. Several of them have first and last. You can see this one actually does not have a size field because this particular one, family members, if you remember from the slide also, it was returning a list directly, not a connection pattern, and it doesn't have a first or last, instead it has a limit argument. I can apply all of those, which means I get down to no more errors, right? Save this into my schema. It's automatically publishing it to my endpoint. So I can go to here to a graphical that's hitting this endpoint, right? And start editing. So I've got an account, right? I ask for account ABC and ask for just the account's name back. I can click here to run. But before I even run, notice that in the bottom left here, we've augmented the graphical to show the data based on the spec, right? So it's telling me that I put in limits for this new API that I just today. I went before the talk and put in limits of 1,000 points of type per minute, type cost, and 1,000 points of field cost per minute. So you can see this one is pretty small. So I'm getting 500 per minute. And you can, if I want to look at details, I can see that actually the field cost is 1, right? Just the account is costing 1. But type, I've got 2 types, the query type and the account type. So that's a type cost of 2. So if it was only about the field cost, I'd be allowed a rate limit of 1,000 per minute. But because the type cost will actually cut me off first, it'll only net give me 500 per minute. So that's details that in developing your schema you're going to be interested in. But the end user running it's more interested in just knowing he gets 500 per minute of this query, right? And I can run it. Let's actually run it and see that come back. It should come back. There we go with the account name. Now I can start asking for more, right? Maybe it's not just the name. Let's say I also want to know, we talked about the joint owner. And what did I want in the joint owner? I can get the name and I don't remember what are the other fields here, the email, stuff like that. You can see now I'm down in my query limits. I'm down to 166 times per minute. If I also want to see the transactions, how many am I going to want? Let's say typical screen, maybe I want the last 5 transactions. And in each one, I want to see the what the amount and the date of the transaction is probably pretty typical. So now I'm down to 71 per minute, right? I can run that. I can prettify it. I can run it, but I'm getting 71. And you see it's just updating as I'm working with my query here. I'm seeing my query limits, right? I just didn't mean to. I just hovered over, and you see the up to the minute documentation that's automatically from the back end. But it's also giving me up to the minute limits from the back end, right? So I see that as I'm constructing my query, okay, 71 per minute, that's okay with me, as opposed to maybe I go to something really expensive. So let's go back, or let's first start actually. What if I want the joint owner's credit card information, right? Let's ask for something that maybe should cost a little more, right? So I want the number and the PIN of his credit card. Yeah. So now I'm down to 66 times per minute because I didn't make credit card very expensive, right? But what if I go in here and I say, no, the credit card type, it is extremely expensive, right? I'm going to make this like 100, right? 100 points. And I want to save that for a credit card, right? And the idea here is, again, maybe credit card is just something I want to steer people away from unless they really mean it. But maybe it's really something very clear, like I get credit card data from a third party. That means going maybe to a different geography for that data center. Maybe it means a third party where I've got an SLA with them that I don't want to be overrunning. So I'm going to give credit card a much higher value, right? So now if I come back here and I start typing, all of a sudden instead of 66, I get 8 per minute, right? Because this credit card is extremely expensive. I can look up the credit card type and get more data about it, see why it's so expensive. I can play around with it, right? If I want, I can go into the details to figure out what's actually expensive. And you can imagine much better UIs here that would show that to me in different ways. But the point here is that the spec enables me to integrate this at a very clear level, right? So I can see I get only 8 per minute, but if I erase the credit card, right, then I'm getting now suddenly, sorry, I have to make it a legal query. I erased too much. I'm getting, instead of 8, 71 per minute, right? And so as the end user, as the API consumer, I don't have to go to the separate web page like we do today for all of these to figure out how to calculate my limits, right? And similarly for threat protection, right? If it exceeds the threat protection limit, I can just show on this screen that it's too big and I won't be able to run it at all. For the rate limits, I can show and it's based on my plan, right? So this is actually using my particular rate limit. When it says I get 71 per minute, that's not only specific to my to my graph right now, right? But do you see these credentials at the top? I put in my client ID. I logged in to my particular user, right? This is me as an API consumer. I get 71 per minute. If I put in a different person's credentials, I would get a different rate limit. So maybe I get 100 per minute or 10,000 per minute if it was credentials that had signed up for a different API plan, right? That was paying for a more expensive API plan. So which API plan I use affects these limits, and then that's all visible in the developer portal. So I can't show too much in this one demo right now, but if the developer portal can be all based on showing me which choices I have, how much money I want to spend per month, and trying out different queries and seeing how much rate I'll get based on my particular plan that I'm thinking of signing up for. Thanks for coming and joining us. And please, like I said, please contact me and let us know about the spec. Any questions about how it's actually implemented in the product I showed. Any questions you have, just contact through either with my information personally or through the organizers of the conference. You can get to me, or send us if you want the slides, or contact us in this discussion link right here. All right, thanks. Thanks for Alan. Thank you, Igor. All right, have a nice day. Thanks, everyone.